Hello everyone, welcome back to the channel. If you are keen on Kubernetes and DevOps, this video is going to change the way you think about the containers. Most of the people believe my pod is running, so my application is also fine. However, in real-time production environments, running does not always mean working. Since Kubernetes is an orchestration platform, its job is not pretty much only to start the containers. Its real responsibility is to make sure the containers stay healthy and the container should be usable and the container always is in live. And that is where health checks in Kubernetes comes into the picture. So the health checks are very important in Kubernetes, which we can use to make sure our containers are alive and it will be ready to use them. Today, we are going to understand what exactly health checks are, why Kubernetes need the health checks, and then we'll focus on how Kubernetes decides healthy or unhealthy. And finally, we will see one real-time use cases where the health checks will be very useful in our day-to-day activities. So let's get started. Why health checks are pretty much required in Kubernetes. So first, forget service and traffic for a minute. You can parking that part aside. Let's only talk about the deployment behavior now. When you create a deployment, what does it do? Basically, it just creates parts. If pod crashes or if pod gets deleted or if the pod stops, Kubernetes will recreate a new pod, right? However, here is the real problems comes. What if the pod is running, but your application inside is stuck, hung, or broken? So Kubernetes will think pod is running, container is running, but users cannot use the application. So again, we come back to the core orchestration question here. Why do we need orchestration here? It is not just about the running the containers. You also need to make sure the containers are healthy or not. And that is where health checks comes into the picture, and they are pretty much important in Kubernetes to make sure all the containers are healthy or not. Health check basically tells Kubernetes to don't just see whether my pod is running or not. You can go inside the container and check whether my application is actually fine or not. So that is how the health checks will give the input to Kubernetes. Once health checks are given the inputs to Kubernetes, what exactly Kubernetes does? Kubernetes gives you an option inside a pod definition file or pod manifest file, which is called health check. When you create a pod, you can tell Kubernetes what command or script to run, how frequently to run it, whether you want to run it in every 30 seconds or every 60 seconds or every 2 minutes. Based on that, Kubernetes will go inside every replica inside that container and run that check very frequently based on the time interval. Kubernetes itself does not know your application. It will only do one thing is run the command or script which is given by you. Once the command or script has run by the Kubernetes, then Kubernetes will only look at one thing that is called a return code, which is called output. If exit code is 0, container is healthy. If exit code is non-zero, container is unhealthy. So that means when you execute a command, if the exit code or output if we see 0, that means the container is healthy. If the exit code or output we can see non-zero, that means the container is unhealthy. Same way, if we can run any command in the Linux, if we can put echo dollar question mark, we can come to know what is the written code of previous command status. The same way here also, if you execute the command or script by the Kubernetes, if exit code is 0, container is healthy. If exit code is non-zero, container is unhealthy. That's it. Okay, so it becomes our responsibility to create the script or command in such a way that it properly checks the application is healthy or not. As per the requirement, our responsibility is to create a scripts or commands where these scripts and commands we can keep, or where this script should exist. And once again, Kubernetes will go inside the container and run this. That is why when you build a Docker images, we don't only put the application code, we must also put startup scripts, or you can put the stop scripts, and even if you want other commands also we can keep that, and along with that you can put the health check scripts also, because Kubernetes will go inside the container image and execute them. If the script is not inside the image, Kubernetes cannot run it. If the script is available inside the image, Kubernetes will go to the inside the container image and it will run it. So while creating the images, you must make sure all the required scripts are available inside the image itself. Eventually, when the container starts, everything needed for health checks is already there. This is where image design becomes very much important. Okay. Now Kubernetes provides two types of health checks. You can do on a pod level or container level. So one is called liveness check, which is called as a liveness probe, and the second one is called a readiness check or readiness probe. Here probe means checking very frequently and getting the status code, which is called output. Okay, we will discuss these two types of health checks in the coming classes with the detailed information. What is the liveness probe and what is the readiness probe, where we can use liveness probe and where we can use the readiness probe. Liveness probe means, as the name says, a liveness probe is used to identify whether your application is alive or not. A readiness probe means, a readiness does not mean alive. A readiness means ready to serve the traffic. Okay, so we will discuss these two probes in the next class with the detailed information, with the examples and with the practical live demo. Okay, so but we will see one real-time use cases where we can use the health checks in Kubernetes. Suppose you deployed a payment application in Kubernetes with the manifest file. Now the pod is running, container is running. However, database connection is lost. Your application process is alive, but it cannot process the payments. If you don't have readiness probe, users will keep hitting that pod, payments will fail. This is production incident. But if you have a readiness probe, the moment DB connection fails, your script returns non-zero. Then that time Kubernetes will immediately remove this pod from the traffic and the users will be sent only to the healthy pods. Despite of one pod is failing internally, your application stays stable. That is where health checks saves real production systems. Okay. Coming to the summary, in today, what we discussed is why health checks are pretty much required, how Kubernetes execute them, what scripts do, or what the commands do, what zero and non-zero means, and we have seen one real-time use cases. In the next video, we will go very deep into what is a liveness probe and where we can use it, and what is a readiness check and what exactly that does. And we'll see couple of checks like HTTP or command or TCP checks. And I will explain in the live demo with the YAML file example. So make sure you subscribe this channel because that video will be completely practical. Okay, so if this video helped you, could you please like this video, share it your technical hurdles, and comment below what topic if you want to next. Since Kubernetes learning is not about theory, it is about understanding how practically really behaves. It is about understanding how production really behaves. This is where real DevOps start. So see you in the next video. Have a nice day.